All right, welcome back to the. Okay, so we're having 9 exponent x minus 6 exponent x is equal to 4 exponent x. Okay, so what we are going to do is divide each part by any. Okay, so I am going to choose 4 exponent x. So I'm going to divide each part by 4 exponent x. So I divide here by 4 exponent x, here by 4 exponent x, here by 4 exponent x. Okay, now in indices, we know that if you're having a exponent b over c exponent b, this is the same as a over c, okay, exponent b. So you're going to apply this concept here. Okay, so you're going to have 9 over 4 exponent x minus 6 over 4. Let's do corrections here. 6 over 4 exponent x is equal to 4 over 4 exponent x. Okay, so this is what you're going to have. All right. All right. Now we know that 9 is the same as 3 times 3. Okay, so we can write 3 times 3. Let's do corrections. 3 times 3. 3 times 3 over 2 times 2. Okay, exponent x minus this 6 can be written as 3 times 2. This 4 can be written as 2 times 2. Exponent x is equal to 4 over 4 is 1. 1 exponent x is 1. Okay, now let's do something here. Now these two will cancel these two here. Okay, okay, so now we're going to have 3. Okay, so the equation becomes 3 over 2 x times 3 over 2 x, okay, minus 3 over 2 x is equal to 1. I know you are asking why I did this. Okay, now I'm going to show you why I did it. Okay, now okay, we know that a times b exponent x is equal to a exponent x times b exponent x. Okay, so this is the concept I applied. Okay, all right, now let's proceed. Now we can see we have 3 exponent 2 at the right part of the equation. Okay, so what we are going to do is to represent 3 over 2. Sorry, we have 3 over 2 exponent x, okay, at the right part of the equation. Okay, so the first part, you have 3 exponent 2 exponent x times 3 over 2 exponent x, okay, minus 3 over 2 exponent x, okay. So we say let, okay, so we say let a represent 3 over 2 exponent x. So wherever we see 3 over 2 exponent x, we are going to write a. Okay, so our equation is going to be a times a, okay, a times a minus a, okay, minus a is equal to 1. So you're going to have a squared minus a is equal to 1. Are you there? All right, now let's rewrite the equation again. So we're going to have a squared minus a minus 1 is equal to 0. So this is a quadratic equation. Okay, now let's apply the quadratic formula. Okay, so we know that, okay, we know that a should be minus b plus or minus root of b squared minus 4ac. Let's change this. 4ac. Let's change this again. 4ac all over 2a. Okay, so let's put in the values. So you're going to have, okay, a is equal to minus 1 plus or minus root of, okay, let's write the root again. Root of, now b squared is going to be minus 1 squared minus 4, a is 1, and then c is minus 1 all over 2 by 1. So let's solve. All right, so we solved and we had a1 is equal to 1 plus root 5 over 2, and then a2 to be 1 minus root 5. Let's correct something here. 1 minus root 5 over 2. Okay, now we had already said that a is equal to 3 over 2 exponent. Okay, 3 exponent 2, 3 over 2 exponent x. Let's clean something here. Okay, we had already said a is equal to 3 over 2 exponent x. Okay, so here we are going to put in the values of x into a. Do you get me? We are going to equate a to its actual values. Do you get me? So now let's start with a2. Okay, now when you punch a2, which is 1 minus root 5 over 2 on the calculator, it gives you a negative answer. Do you get me? When you punch, okay, when you punch a2, which is equal to 1 minus root 5 over 2 on the calculator, it gives you a negative answer. Okay, but then if you look at a is equal to 3 over 2 exponent x, if you put in any values for x at all, it gives you a positive answer. This means that you cannot equate, okay, 3 over 2x, or this means 3 over 2 exponent x is not equal to 1 minus root 5 over 2. Okay, the reason is that the left part is giving you a positive answer, whereas the right part is giving you a negative answer. So the equation does not hold. Okay, now let's solve for a1. Okay, now we can say that, okay, 3 over 2 exponent x is equal to 1 plus root 5 over 2. Okay, this is what we have. Now let's introduce logarithm here. Okay, so we can say, okay, let's introduce logarithm here. Okay, so you can say log, okay, 3 over 2 exponent x is equal to log 1 plus, okay, root 5 all over 2. You can bring a bracket here. Okay, so this is what you have. Okay, now let's introduce a law of indices here. We know that log of a to exponent n to the base b is equal to n log a to the base of b. Do you get me? All right. Now let's apply this concept to the right part of the equation. Okay, so when we do that, we are going to have x log, okay, 3 over 2 is equal to, okay, log, okay, now log 1 plus root 5 all over 2. Okay, so we know the value for this. When you punch this on a calculator, it gives you a value. Okay, so here I prefer to write the actual values. The actual value. So this gives us, okay, 1.618. Okay, sorry. Okay, it gives us 0.2089874. So this is the actual value for log 1 plus root 5 all over 2. Okay, now let's proceed. Okay, sorry. All right. Okay, so here we're going to divide this part. Okay, we're going to divide this part by log 3 over 2, and then here 2 by log 3 over 2. Are you there? All right. Now this will cancel this. Okay, so you're going to have x is equal to 0. This is 0. Let's correct it. This is 0.20898.764. I'm writing all the values because of the demonstration. Okay. All right. Now log 3 over 2 is also, okay, log 3 over 2 can be written as, or the values for log 3 over 2 is 0.1760912591. Okay, so you're dividing the numerator by the denominator and then you have the exact value. And when you do, you are going to get 1.1 1.1 1.186 814383886. Okay, so this becomes our final answer. Now note that I'm writing all the values because I want you to get a concept, but you can actually approximate it to 3 or 4 decimal places.